Hello, everyone. Obviously, again, I am not in today. Still not feeling too well. I am recording this video on Tuesday afternoon. We are moving on today to lesson 2 of Unit 4. You should have once again received a handout that we will go through as I go through the examples here. So make sure you have that handout ready and you're filling it in as I'm going through these examples. First of all, our lesson notes are part repeat from yesterday. So these are repeat from yesterday. Really, the new thing we're going to get into today is this idea of function notation. Function notation is a special type of mathematical notation that we use for functions. Okay. And this is kind of the template we're going to use. So the name of the function is the variable that will go on the outside of the parentheses. In this particular example here, the function name is f. The input of the function, the variable that we use as the input, our x variable, will go on the inside of the parentheses. So that variable could be x, t, n, really doesn't matter. But whatever your independent or x variable is, that goes on the inside of the parentheses. And then the total thing put together is your output. So the number that is inside of the parentheses, we're going to substitute for the variable. Okay. So now we're going to go to the handout. We're first going to take a look at the warm-up, which is on page 1. So let's go ahead and take a look at that warm-up. Okay. So here are the graphs of some situations that you've seen before. Each graph represents the distance of a dog from a post as a function of time since the dog owner left to purchase something from the store. So remember, this was something we did in yesterday's lesson. Distance is measured in feet and time is measured in seconds. Use the given graphs to answer these questions about each of the 3 days. How far away was the dog from the post 60 seconds after the owner left? So on day 1, we're going to look at this graph right here. We'll actually answer all of these for day 1 first. So for day 1, how far away was the dog from the post 60 seconds after the owner left? So 60 seconds after the owner left is right here. And if we look, it looks like the owner was 4 feet away from the post. So that will be 4 feet. How far away was the dog from the post when the owner left? So at the time that the owner left, that would be at time 0. So that would be 1.5, about 1.5 feet. We'll estimate it at that. The owner returned 160 seconds after he left. How far away was the dog from the post at that time? So 160 seconds is here. So if we kind of line up here, it looks like it's somewhere between 3 and 4. But it looks to me like it's a little bit closer to 4 than it is to 3. So I'm going to estimate that at, say, 3.8 feet. We don't know if that's the exact number, but just based on where it lines up, it looks like it's about 3.8 feet. It's definitely between 3 and 4, but closer to 4. How many seconds passed before the dog reached the farthest point it could reach from the post? So the farthest point it could reach, remember the leash was 5 feet long. So the farthest it could be is 5 feet from the post. So when was it 5 feet from the post? It was at this point right here. And if we kind of see where that lines up, looks like it's somewhere between 40 and 60. I'm going to estimate that as about, we're going to say 50 seconds. Okay. It looks like it could be about halfway between 40 and 60. So once again, we'll use that as our estimate. Okay. So that was day one. Let's do the same questions for day two. So I'll use green for this one. So how far away was the dog from the post? 60 seconds. So 60 seconds after the dog left. All right, if we take a look at that, it looks like it's 4 feet away. So it will be 4 feet again for day two. Okay. How far away was the dog from the post when the owner left? So that would be again times 0, which is here, times 0. Again, that looks about like 1.5 feet to me. Okay. Owner returned 160 seconds after he left. How far away was the dog from the post at the time? So 160 seconds is here. It looks like it's 4 feet again. Okay. How many seconds passed before the dog reached the farthest point it could reach from the post? So the farthest point it could reach was 5 feet. So again, that's right here. All right. It looks like it's just below 40 seconds. All right. It's definitely between 20 and 40, but it looks very close to 40. So I'm going to estimate that at 39 seconds. Okay. Now let's do day 3. So how far away was the dog from the post? 60 seconds. So 60 seconds. Again, it lines up at 4 feet. Okay. How far away was the dog from the post when the owner left? Okay, that's right here. That's this point right here. Again, that's 1.5 feet. 160 seconds. So it looks like it's right here. All right, that looks about halfway between 0 and 1 feet. So we'll say that's a half a foot. All right, 0.5 feet. And then how many seconds passed before the dog could reach its farthest point from the post? So that's about right here. And that's like way at the beginning. It's really close to 0. So I'm going to estimate that at about 1 second. Okay. So we just answered those questions based on these 3 graphs here. Number 2, consider the statement, the dog was 2 feet away from the post after 80 seconds. The dog was 2 feet away from the post after 80 seconds. Do you agree with the statement? So if I look at 80 seconds on day 1, it's definitely not 2 feet. It's more like 2.5 feet. On day 2, after 80 seconds, it's at 4 feet from the post. And at day 3, 80 seconds, it is at 2 feet. So to answer the question, do you agree with the statement? The answer is yes, I do agree. Yes, but for day 3 only. Okay. Day 3 at 80 seconds, it's 2 feet away. But day 2 and day 1, it was not 2 feet away at 80 seconds. All right. Let's take a look at number 3. Okay, what was the distance of the dog from the post 100 seconds after the dog left, or the owner left, excuse me. So day 1, 100 seconds. Okay. It looks like it's just above 2 feet, between 2 and 3. So I'm going to estimate that at 2.1 feet, 2.1, 2.2 feet. 100 seconds for day 2 is here. Okay, that definitely lines up at 4 feet. And day 3, 100 seconds. It looks like it's just above 1. We'll say 1.2 feet. Okay. 100 seconds. Yeah, it's just above 1. So we were just using these graphs to answer the questions in the warm-up. Okay. Let's go to the back of the handout and take a look at those examples now. So use function notation to complete the table below. So let's name the functions that relate the dog's distance from the post and the time since its owner left. Function F for day 1, function G for day 2, and function H for day 3. Okay, so day 1, let's just do day 1 first. We're going to write this function notation. So to go back to our lesson notes, we're going to use this notation here. Okay, the way we say it in this case would be f of t. F of t. So we are naming the function, we're naming the function for day 1, we're naming it function f. So for each of these, there's going to be an f, okay? The question is, what's going to go in the parentheses, okay? So if I want the distance 60 seconds after the owner left, the function notation would simply be f of 60, okay? The distance after, so f is the name of the function, and then I want my input to be 60 seconds, so it would be f of 60. The distance from the post at the time the owner left, okay, that's at the moment he left is time 0, so that would be f of 0. And the distance from the post 150 seconds after the owner left, that would be f of 150. So the number that goes in the parentheses is the input or the x variable, which remember in this case is time. Okay. Now day 2 is going to be the same thing, except we're using the function g for day 2. So my distance in the post 60 seconds after the owner left is going to be g of 60. The distance from the post at the time the owner left is going to be g of 0. Okay? And the distance from the post 150 seconds after the owner left is going to be g of 150. Okay? So it's the same exact thing, except we're using a different function name because it's day 2. We're using the function g. And day 3, yet again, is going to be the same thing. It's going to be the same thing, except this time it's going to be the function h for day 3. So this will be h of 60 and h of 0 and h of 150. Okay. So that is the function notation. That is the fancy mathematical notation for these statements here. Okay. Number 2, describe what each expression represents in this context. F of 15. Remember, that is the function name. So f is the function name for day 1. So f signifies that we're dealing with day 1. Okay. And 15 represents a time. So that would be 15 seconds. So f of 15 is going to be day 1, the distance, 15 seconds after the owner left. So f of 15, f is our function for day 1. So f of 15 is going to be the distance 15 seconds after the owner left on day 1. So day 1, the distance 15 seconds after the owner left. g of 48. So now we're dealing with function g, which remember up here says for day 2. So g of 48 tells me we're dealing with day 2. And this is going to tell me the distance 48 seconds after the owner left. So that's going to be the distance 48 seconds after the owner left, but on day 2, because we used the function g. Okay. Let's look at C, h of t. So h tells me we're dealing with day 3. So this is going to be day 3, which will represent the distance. Okay. And this time the input is t. So this is going to be the distance t seconds after the owner left. So the function tells me the day, and the number in the parentheses tells me the time. Okay, so that's number 2. Let's go to number 3 now. Okay, so the equation g of 120 equals 4 can be interpreted to mean on day 2. Okay, why day 2? Because function g stands for day 2. Okay, so g of 120 equals 4 can be interpreted to mean on day 2, 120 seconds after the owner left, the dog was 4 feet from the post. What does each equation mean in this situation? So we're going to use this example. Let me underline it. Okay, I'm going to use this example here as a model to answer the 3 questions. So number 3, the equation g of 120 equals 4 can be interpreted to mean on day 2, 120 seconds after the owner left, the dog was 4 feet from the post. What does each equation mean? Let's start with A. Okay. H of 40 equals 4.6. So first we're dealing with function h, which in this case is day 3 up here. So this is going to mean on day 3, okay, our input is 40. That means 40 seconds. So 40 seconds after the dog owner left, the dog was up here. After the equal sign was 4, that meant 4 feet. In this case, after the equal sign is 4.6. So this time we're going to say the dog was 4.6 feet from the post. So on day 3, 40 seconds after the dog owner left, the dog was 4.6 feet from the post. Okay. B, we have f at 0 equals 1.5. So function f, right, up here, remember, function f is for day 1. So this is telling me that on day 1, the number that's in the parentheses this time is 0. So that means 0 seconds after the dog owner left, the dog was, in this case, after the equal sign is 1.5. So the dog was 1.5 feet from the post. On day 1, 0 seconds after the dog owner left, the dog was 1.5 feet from the post. Okay. And let's finish off with C. G of 4 equals 5. So function G is for day 2. So this is going to be on day 2. So on day 2, all right, my input, the number in the parentheses is 4. So this is on day 2, 4 seconds. 4 seconds after the dog owner left, the dog was, all right, after the equal sign is 5. So this is telling me that the dog owner was 5 feet from the post. So on day 2, 4 seconds after the dog owner left, the dog was 5 feet away from the post. So that is number 3. Let's finish off with number 4. Okay. Number 4, basically, we're going to go backwards. So on number 3, we started in function notation, and then we wrote the words, we wrote what it means in context. And then in number 4, we're going to do the opposite. So we're going to start with the words, and then we're going to write the function notation. Okay, so it's like Jeopardy. We're going backwards. So on day 1, 20 seconds after the dog owner left, the dog was 3 feet from the post. So day 1, let's go back to the top here. Day 1 is function f. So that means when I write my function notation, I'm going to use function f. Okay. My input is 20 seconds after the dog owner left. So this is going to be f of 20. The dog was 3 feet from the post. So that is your output. That goes after the equal sign. So on day 1, 20 seconds after the dog owner left, the dog was 3 feet away from the post. The function notation would be f of 20 equals 3. Okay. On day 2, 60 seconds after the dog owner left, the dog was 5 feet from the post. So day 2, if we go back up top here, day 2 is function G. So my function is going to be G. My input, my time is 60 seconds. So this would be G of 60. The dog was 5 feet away from the post. So G of 60 equals 5. Okay. On day 3, 1 second after the dog owner left, the dog was 5 feet away from the post. So on day 3, 1 second after the dog owner left, the dog was 5 feet away from the post. So remember, day 3, according to up here, day 3 was function H. Okay. So on day 3, 1 second after the dog owner left, the dog was 5 feet away from the post. So that's going to be function H. All right. The time is 1 second. So this will be H of 1. 1 goes in the parentheses. 1 is the input. The dog was 5 feet away from the post. So H of 1 equals 5. Okay. So that is the entire backside of the handout. That is it for the lesson for today. What I want to do now is I want to take a look at your cooldown for this lesson to give you an idea of what it looks like. So let me just quickly go through that cooldown for you. Okay. So this is what you're going to do for your cooldown. Okay. So function Q gives a puppy's weight in pounds as a function of its age in months. So in your cooldown, instead of talking about distance and time, okay, in this case, the distance is going to be like the weight, and the age is going to be like the time. That's going to be whatever the age is. That's going to be the number that goes in the parentheses. Okay. So that is what you're going to do with your cooldown. Obviously, email me if you have any questions. I should be back tomorrow.